Hello. Hey everyone. Welcome to the Civo Hackathon. I'm super excited for this. So I'm Kunal. I work as a developer advocate at Civo, and now we're starting with the official Civo 2021 Hackathon. So it's an initiative to bring together people to innovate and build projects using Civo. So in Civo we have services like the Civo Kubernetes, we have Civo Compute. So we'll talk more about that later. I'll just give a huge shout out to all the amazing speakers that are going to be joining us today, and I'm super excited for this event. By the way, you can still register if you haven't already. I'll share the link in the comments. Right now, you can form a team of, let's say, up to 4 people, or you can join like solo as well. Totally up to you. We have some amazing prizes. So the first prize is 2,500 US dollars in cash prize. You also get like some nice Civo bag, some swag bag, and all these other things. And the second prize is 1,500. Third one is $1,000, and then we have category wise prizes as well. So in case you make a best serverless hack, so you have like $500 for that. Best use of monitoring, which Sanyam will talk about later. During the just during his session, which is going to be on you know um, introduction to Kubernetes monitoring, and best IoT hack. So hackathons are not just for like coding peeps. So in case you're interested in building some hardware hacks or whatever IoT and stuff like that, you can use Civo with that as well, and you can um, win best IoT hack prize as well. Cool. So the requirements and the project submission and everything is mentioned on the website that I've just shared. It's also in the description below. And use of Civo is mandatory, obviously, since it's a Civo specific hackathon. You can sign up to Civo, and you will get a $250 worth of credit. People who are asking like, is the credit card is mandatory and stuff? Yes, it is, but I would not worry much about it because the pricing is very transparent. And since you're making a project like for your own, like just the hackathon purpose, let's say, I think it should be fine. $250 worth of credit, but the pricing is transparent. You'll see everything like when you create your clusters and everything. It's a 3-day event, so we'll be announcing prices after the event is over. But let's get started. So today we're doing like today we're doing workshops. So we have some amazing workshops lined up for you. And one thing I would highly recommend is join the hashtag hackathon channel in the Civo Slack community. There you can ask all your questions, see what others are working on, and the most important part, ask doubts. So if you have any doubts, technical queries, things like that, you can ask it in the channel. Let's get started. So this one, I'm going to be joined by Alistair in a bit. So we are going to talk about an introduction to Kubernetes and containerd. So since you're going to be innovating on Kubernetes projects and things like that, it's important to also talk a little bit more about it. One thing I would like to share is if you want to learn more about like Kubernetes, let me just share the link. You can go here, civo.io slash sorry, not io, civo. I'll just share the entire link. Academy. There we go. civo.com/academy. This is the one. So you can go to this link and you can learn Kubernetes for free. Cool. I'm gonna put Alistair on the call over here as well. Alistair, thanks for joining. Would you like to tell our viewers a little bit more about yourself?
Yeah, hi everyone. Thanks for tuning in. I'm Alistair Hay. I'm a cloud native platform engineer. I run my own business doing consulting and contracting. So, happy to be here, and hopefully we can all learn some stuff together. So, thanks.
Awesome. Cool. So let me just bring up my presentation. If you have any questions, feel free to ask those in the chat as well. Let me just. Share my screen real quick. Cool. I believe you can see. So yeah, let's get started. Before we move on to like the Kubernetes part, I want to give like a brief overview about like containers and stuff. So when we talk about like containers and things like that, imagine you want to ship all these items, right? You want to ship a box like with you want to ship like from one country to another, a car, some servers, some balls, a piano, grains, or whatever. So wouldn't it be easier to like put everything in a box and then ship that box to like one country to another? irrespective of how individual items will be shipped. So it's more like you wonder, hey, can I quickly transport this thing from a boat to a train to a truck or whatever. Similarly, you can imagine if you have a website, so you have a static website, you have some databases, you have a front end and back end and caching and all these things, and you give your website to a friend, and your friend is like, you give the code to your friend, and your friend is like, hey, I'm not able to run it because it's missing this module, it's missing this version or that version or these dependencies or whatever. So you put all these things inside a box and you give your box to that friend. Right now, it makes sure that it will run easily. So this is sort of like the idea of containers. This is how it's like sort of like different, like virtual machines versus containers. People often ask, do you use virtual machines or containers? It's not like a this or that question. You like in reality you run like containers on top of virtual machines, so you can create your own compute like instances and things like that in Civo as well. By the way, we'll be doing a demo of that as well. And Ais will be presenting, and I'll be also presenting on how you can launch your application in Civo. That's also going to be happening today, so make sure you check out the Civo YouTube channel and give us a subscribe while you're at it. So as you can see, like in virtual machines, you might have done like something like dual booting or something like that. You install Windows on one and some Linux distro on some other. So what happens is you have to like divide the hard disk space, install an operating system on that, and do all these other things. This becomes a little bit slow, and like obviously sometimes like space is wasted, like if you're not utilizing it properly. Containers on the other hand are extremely like fast as compared to spinning up a virtual machine. If I run this Docker over here, for example, which we'll look more into like the container runtimes and things like that later on, but you can see that it will be able to run it relatively faster, because it's not like installing like a whole new operating system or whatever. It's using the host operating system only, but the only difference is you have now a container engine, for example Docker or something like that. Okay, so something, okay, never mind. So that's basically like about Docker and stuff. We're not going to talk more about that in detail structure of that, but say we are talking about containers. So in containers, what happens is that let's say you're running a large number of containers. What are containers? Containers are just running instances of your applications, right? So all these are the big companies like Tinder and Google and all these other companies. They run their applications inside containers, and in order to run an application inside a container, you need an image. So an image is basically like a recipe. So for example, you have a recipe list, right? It lists all the ingredients and how to prepare, the quantity and everything. You follow that recipe, then you create a dish. Similarly, when you follow a Docker file, you create an image. Using that image, you can create a Docker container, right? Cool. So Kubernetes comes into picture when you have to manage a large number of containers, and so imagine that your application is running inside a few containers, and let's say now 100,000 people start using our application. So you want to create more instances of your application on more servers. You want to distribute the load, or for example, less number of people are using, and you have more than what is required number of instances running. You have to reduce those. For example, other thing can be some of the pods, or which we'll talk more about later. Some of the instances of your application, let's say, stopped running, they got corrupted. You want to restart those. Okay. So many things you want to do. Wouldn't it be great if there was like an automated way to do it? Then there comes into picture Kubernetes. One of the use cases it provides is it's not just a container orchestration engine. It provides a lot more features, but one of the use cases is container orchestration, and was open sourced by Google in 2014. So in simple terms, it makes it easier for us to manage containers by automating all these tasks and various tasks that I just mentioned. Alistair, would you like to add on to it?
No, I think you've covered most of it. The extra stuff it does on top of container orchestration is where it really shines above some of the rest of the competition. I think Docker Swarm was one of the others that was competing with it around when it was released, but Kubernetes is sort of integrated with a lot more. You've got volumes, you've got integrations with load balancers and stuff. So it's kind of, the fun with Kubernetes comes above that orchestration layer, even though it is very, very good at it as well.
Cool. So yeah, you can use it as a container orchestration to automate like deploying, scaling, and managing your containerized application on a group of servers, right? So let's talk a little bit more about how it works, the architecture. So this is a Kubernetes, like the basic architecture. You have your worker nodes. This you can imagine nodes as like virtual machines or racks of servers or whatever you want to call it. Inside like these nodes, you have like pods. So pods are basically like it's the scheduling unit in Kubernetes. Inside a pod, you will find a container. This can be a Docker container or whatever. A collection of all these is known as a Kubernetes cluster, right? And this is the master node. The master node will dive into details of this as well. The use of this is to manage all the other worker nodes, for example. But this is like an overview. Let's look into like the more inside picture. So this is a master node. So master node has a few components. You have the scheduler, you have API server, control manager, you have these the ways you interact with it or whatever. So it's basically just responsible for managing the entire cluster. It monitors the health check of like your worker nodes. So for example, if a worker node fails, the master node will move like load from one node to another healthy node. It can start new, new schedule new nodes and all these other things. It takes care of it. Cool. A little bit more about its components. So you can see API over here. You can see API server, etcd, and scheduler, and all these other things. So let's look into what each and every one offers. So API server, it's sort of like a gateway for the entire cluster. So all your CRUD operations go through this, for the servers, go through this API, which is known as like kubectl. You can also use a graphical user interface if you want. So when you write kubectl, get all the pods, for example. So it's going to go from the API, like it's going to, that's the Kubernetes API. It's going to make a call to the API server. And then the API server is going to be like, okay, oh, you want all the pods? Here are all the pods. You want all the like, all the deployments or whatever. Here are all the deployments or services or any information you want. So like any information about like these Kubernetes objects that you want. Scheduler is basically responsible for physically scheduling pods across multiple nodes. So you give a command like, hey, create a pod or schedule some pods or schedule this application, for example. If I'm talking in simple language, then scheduler is going to take care of it, like actually putting it on the across multiple nodes. Control manager is the one that ensures that nodes are up and running all the time, as well as the correct number of pods are running. So, for example, in your deployments or whatever, you want to say, hey, I always want you to run at least 3 pods, okay, or 3 replicas or whatever, something like that. So even if one goes down, it will automatically spin up another one. It will make sure at all the time, let's say 3 nodes are running. Okay, so control manager will take care of that. etcd is just like a database, so it contains like the cluster state and all these other things. So if the API server needs any information, it can contact etcd. In general, this is just like how the master node works. You'll be working heavily with kubectl when developing on Kubernetes. You'll definitely see that in the hands-on demos as well. Okay, we have hands-on workshops. You can find all the ones that are already scheduled in the on the Civo YouTube channel. So make sure you check it out. Now the worker nodes, it's basically like any virtual machine or a physical server where containers are deployed. This is sort of like the architecture for it. You have the over here, you can see the API server talks to the kubelet. Now what is kubelet? Kubelet is the primary node agent on every worker node. It basically ensures that the containers described in the specification that you provide are running and healthy. So in the specification, you provide so many things, right? You can say this much RAM is required. You can say this much CPU power is required, or these many you should run containers. This is the application you should run. This is how you should run it, and all these other things. So this is sort of like the primary node agent that manages that. Okay, so that's the kubelet. Kube proxy, basically, if you want to contact the outside world in simple terms, like the internet, for example. So you can use that. Also, it can be used to expose services to the outside world. So kube proxy helps us in doing that. Pod is a scheduling unit in Kubernetes. It's sort of like a virtual machine in the virtualization world, and every single pod can contain one or more containers. It's like a convention to put like one container inside a pod. If you have like a MongoDB application running and a front-end application running and Node.js running, recommended way is to put all these 3 in different pods, right? So that you can scale those individually and makes it easier for you to debug. Pods can obviously talk to one another, and containers can talk to one another and stuff. Yeah, that's basically about it. I'll show a demo of this as well in the second last session of the day. Yeah, Alistair, go ahead.
Yeah, one of the main benefits of being able to run more than one container in a pod is for sort of sidecar services. So services like if you want to ship your logs across, you can have a sidecar that's not part of your main application, or you can have something which fetches secrets. So yeah, like Kunal said, rather than putting your entire application in one pod, that's not really the idea behind multiple containers. It's more these sort of extra services that aren't part of your main application, but they're kind of helpers. So yeah, that's a pattern that you see people putting all their app into one pod and just deploying the whole lot. It doesn't scale very well because you might need 10 API nodes and only one database pod. So it kind of reduces the efficiency of using Kubernetes essentially.
Yep. Thanks for sharing, Alistair. But yeah, that's basically about it. And containers, you already know. We talked about it. Just running instance of your applications, of your images. Cool. Overall, it looks somewhat like this. So you use kubectl, you say, hey, please make some pods or whatever internally, then all these things can happen. Cool. Installation. So cloud platforms you can use, like, this is a very, very old slide. So you can use something like play with K8s, which is something like just for testing purpose. If you're using on your own local machine, you can use something like Minikube. You can use kubeadm, but for cloud, for this, like you can use Civo Kubernetes. So in order to get started with that, we'll be running an application with Anais. We're running a workshop with Anais. So she's going to go through like how you can use Civo Kubernetes. I'll just show you. Civo.com. Oops, not the hackathon. Civo.com. So you can sign up and you can log in and stuff, and then you can create your own clusters or your compute instances and things like that. Just create one and you'll be able to do so. But we'll be doing like a separate video on this later on. Pod lifecycle is nothing. It's just like how the pods run. So pending state, running state, fail state. One more thing I want to share about like Civo platform is that not me. I'll give Alistair this one. Alistair, can you maybe share what benefits you may have like using Civo for Kubernetes?
Yeah, so one of the problems with some of the managed cloud Kubernetes, and if you're doing it yourself as well, for production especially, is some of the large cloud providers can take 20 or 30 minutes to spin up a Kubernetes cluster, which is fine if you're only doing it once. But if you want lots of clusters, or you're going to treat your clusters a bit more like for testing purposes, or you just want a cluster to do something else, Civo can spin them up in about, is it 90 seconds? About 90 seconds.
Yeah.
So it's really quick to get up a, decent Kubernetes cluster with a good amount of storage, with transparent pricing, in 90 seconds, and you're ready to go.
Yep, that's correct. And I was just trying to find that tweet as well. On my account, there was someone from GitLab, they made a tweet. That's what I was trying to find. Let me just do that and share with you. So they gave a really nice example of this thing. That's what I was like, let me share. But yeah, and also we have like the transparent pricing. There's the marketplace, which we'll talk more about later. You can use the Civo marketplace and make all these, with other projects like support for them. So you can check that out as well, and you can definitely use it in your own.
Yeah, another benefit is the Civo Slack. So sign up, you get an invite to the Civo Slack, and you get access to the community and experts and people from Civo. So if you've got any questions or problems, or you want pointing at some more learning resources, then the Slack's really great for getting involved.
Yep, this is the one I was talking about. I love this tweet a lot. So hey, you need a GitLab instance. Oh, what do you need at the end of the week? How about in less than 15 minutes? And then Civo. So it's pretty cool. You can check out this blog. So I'm trying to find. But this is what I meant by marketplace. So when you'll be developing your own applications, you can check out this thing. To create a cluster, and here in the marketplace, you can select all these applications like for databases, and we have the best monitoring price as well. So you can use something like Prometheus over here. Yeah, you can use Loki or something like that. Yeah, that's this. what you wanted to share. Yep. Cool. Let's move forward. So a pod, basically, when you this is something I believe would make much more sense when we do the hands-on demo. But yeah, that's pretty much about it. And this is sort of like the file that you use to create a Kubernetes object. So you have the kind pod, you have the metadata, which basically you want to add some labels to it or whatever. And the spec basically mentions about the containers and things like that. So let's say from the name of the container is going to be, let's say, nginx container, image is nginx. It's going to take it from the cloud, like Docker Hub or whatever, and then it's going to run a container, a pod inside which the nginx container is running. These are just some basic commands. Obviously, you can find those in the academy as well. That is what I would highly recommend you to check it out. But yeah, I'm going to now give it over to Alistair, who's going to tell a little bit more about the containerd and container runtimes.
Yeah, sure. Let me share my screen. Oh, no, the other one. Cool. I'm going to put this in present mode. So if you've got any questions, please put them in the chat. I'm going to rely on Kunal for stopping me and raising those, because I only have a single screen. All I can see now is my presentation. So yeah, don't be afraid to ask any questions. There's no such thing as a silly question, because we're going to go through quite a lot of content and topics, and some of them can be quite complicated. So yeah, and Kunal as well, if you think anything needs any more clarity, just stop me and ask. So yeah, we're gonna have a look at what a container runtime is. We've spoken a lot about containers, and we've kind of washed over how you actually, what happens under the hood when you want to run a container, and what kind of programs and things are involved. So we're going to look at what a container runtime is, what it does. We're going to just briefly look at a few options, and then we're going to look at how the container runtime integrates with Kubernetes. So when you run your Kubernetes worker nodes, how the kubelet actually talks to the container runtime, and that then will run the containers. So we're going to have a quick look at that and how it all kind of glues together. So yeah, what is a container runtime? It's a software component that you install on your machine, on your worker node, on your virtual machine, that manages these things. So, pulling in images, creating networks, dealing with storage. So if your container needs to mount a volume on the host, it will manage that. Process isolation. So one of the benefits of using containers that we've touched upon is you can run lots of containers on a single host. So you can use much more of the available resources, whether that's CPU or memory. But what we don't want is all of the processes, all of the containers that are running on that host to be able to kind of talk to each other or see what each other's doing, because you might have like a sensitive application running here and you don't want other things to be able to talk to it. Resource constraints as well. So if you've got like 10 gigs of RAM on your machine, you want to be able to say, well, this container can only use 1 and this one can use 5, because if your one that you said can only use 1 didn't have a constraint, it would just be able to just keep using memory and memory and memory, and then it might impact your other containers that are running. So that's kind of this noisy neighbor problem. And secrets as well. So mounting secrets and volumes and environment variables, that's kind of a catch-all for, it's sort of a storage thing, but it's a special case of storage. So your container runtime will like either create a file and mount that inside the volume, inside your container, or it will pass in an environment variable for you. So rather than putting your secret in your container image that you create, which is a really bad idea, we can pass those in at runtime, so that they don't get exposed on Docker Hub or wherever. So the first of these is image management. So your container images generally will live in a container registry. So most of the time that's either Docker Hub or GitHub Container Registry, or Amazon AWS ECR. So your container runtime needs to be able to pull your container image, and a container image is just a set of files. It's essentially a mini file system. So when your container runtime pulls it, it will save it onto the host onto the VM or the host or your machine as a set of files, ready to be run a little bit later on. They also manage and set up networking, and on Linux you have these things called network interfaces on your machine, and depending on how they're all configured and they're wired together, your container will either be able to be reached from the outside world. You might only be able to reach it from your machine, so it's not exposed on the host. There's all sorts of options. So this is an example here of a container which is exposed on the host's network interface via the container network interface. So all containers will get their own network interface. And that network interface, if you don't explicitly add it to the host network, it'll be very isolated. It will just essentially won't know that anything else exists outside it. But in this example, we've allowed ingress from the outside world through the host into the container. So if you had many containers, you could have many of these lines coming through the host's network interface, that big blue one on the bottom. You could have as many containers running in there as you want. We touched on storage. So containers will get themselves like a sort of sandbox amount of storage that they can use for saving files. They can read files from the disk as long as it's inside their sandbox. So if you have a long-running process that needs to write files and then read them back later on, your container has this sort of space, and also then mounting volumes from the host. So if you're running, say, a MongoDB database on your machine, on your host, if you wanted to persist data between container restarts, so if your container dies and you haven't mounted a host volume, all of your data will be lost. It will just disappear. And that might be what you want. If you're using these for testing as part of CI, you'd bring up a new container with absolutely nothing in it, and you'd add your data in that you needed for your tests. But if you're running this while you're developing and you want your data to persist, for days or weeks while you're working on a feature, then you'd mount a volume on the host. You'd create this space on your host machine, and your container runtime you'd be able to specify that you wanted to mount that into your container so that every time it restarted, that data is there and available. So if you make changes, they persist. We've talked as well about process isolation. So you've probably seen an image like this. This is actually from Docker, talking about what containers are. So app A can't see what's happening in app B and so on. So it would be pretty bad from a security standpoint if our applications could see what each other were doing. This is really important in Kubernetes workloads because you don't know which apps are going to be scheduled on which nodes. So you may end up with, a really sensitive workload right next to, you can't specify which one goes where. Well, you can, but you probably shouldn't. So it isolated these processes. So app A wouldn't even know that app B or C or D exists, or the host operating system. So essentially the container runtime will kind of sandbox or block away that application. It won't be aware of what's going on outside it.
They can obviously talk to each other, right? And we'll do a demo of that later on.
They can talk to each other over network, which is different to process. Yeah. So if you're running on your machine, I don't know, might be able to do a demo of it if we've got a bit of time, but the process running in app A on your machine won't be able to see the memory or what's happening it won't be able to see the process in app B, but it can talk to it over network using that network thing we did earlier. If we can expose or link the two containers over the network, or through a shared mounted volume. And there's all sorts of ways the two can, if you want them to, but by default, they will be kind of separated and isolated. We talked about resource constraints as well. So one of the things we're trying to solve, one of the things that containers is trying to solve is resource utilization. So you buy, 3 big racks of servers, and if you're going to use a virtual machine for every application, there's a certain amount of memory CPU required to run your virtual machine, and then you run your application, which would be like a tiny slice on top of it. But with containers, you run one virtual machine or one host, and you have lots and lots and lots of containers on there. But we want to share, as we discussed earlier, our CPU and our memory to limit the noisy neighbor problem. So if you've got one container running that's, going mad and getting millions of requests a second, you don't want it to be able to kind of stop all of the other processes that are running on that host. So we can set these in Kubernetes, they're called requests and limits. So you request a certain amount of CPU, like one virtual CPU, but you'd set a limit, say for 2, and if it hit 1, it wouldn't be terminated, but if it hit 2 CPUs, Kubernetes or your container runtime would actually stop that container, say, this has gone way outside of the limits that you've set, and it's doing something weird, and I'm going to stop it. And then it would, in Kubernetes land, it would be rescheduled somewhere else. And if it did it again, it would be killed. But, it's just a way of stopping this noisy neighbor problem where, one rogue container or one container, you've deployed a new version of your application and it doesn't quite work as expected. It won't wipe out all the rest of the components. We'll briefly just talk about why there are more than one container runtime, because they kind of all do roughly the same thing. Most of us will have used containerd. We probably won't have known specifically that we're using containerd, but it came as a spin out of Docker. So Docker open sourced their container runtime, called it containerd. They donated it to the Cloud Native Computing Foundation, and it kind of became the de facto industry standard. The container runtime specification, however, was kind of based off containerd. But there are other options, and there's some interesting ones on the list here, like Kata containers. They kind of take the concept a little bit further, and they run little virtual machines for all of your containers, which is really good if you need very strong process isolation. So say you're running in like a banking environment or financial services or whatever, and you want to really guarantee that your applications can't break out their containers. But yeah, there's loads of other, like Nebula containers, I think is used a lot in Singularity is used in, so there's specific ones for like scientific work and, process isolation. But why have we got so many commercial reasons? Maybe you work for a big company and you want to write your own because it makes you look good, or you've got specific hardware requirements, then maybe you want to write your own. Different requirements, process isolation, Kata containers. We've got speed of launch and isolation. So there's this virtual machine runtime called Firecracker that Amazon use for running AWS Lambda workloads. And there's this containerd Firecracker kind of container runtime, which launches you like a really tiny VM, still using the kind of containerd plugin model. It's pretty cool. And if you want stability and mass adoption, containerd, everyone here's used it if you've used Docker. And also, we're all software engineers, so maybe it's a bit of fun to write a new one. Have a go. There's, So containerd, as we've discussed, industry standard. It's been battle tested. You've all used it. It spun out of Docker in 2017. And it's now a graduated CNCF project. So that puts it on par in terms of adoption and use as Kubernetes, which is a graduated project, and etcd and stuff. So some of these really big names, it's basically the industry standard now. So we've talked about a container runtime in isolation, and we've also talked about Kubernetes. And now we kind of need to think about how Kubernetes can interface with the container runtime to run containers. So in around December 2016, I think it was, the Kubernetes maintainers decided that they were using Docker as the runtime, and they had this software component called the Docker shim.
Yeah, that's correct. Yeah.
And they decided that it might be better to have an interface, a runtime interface, where you can essentially run any other container runtime underneath it. If the Kubernetes maintainers maintain this interface, which is like a contract between the two services. So Kubernetes would say, I want you to run a container, and that runtime that lives underneath the interface, as long as it implements the same interface. There's too many words for interface here. As long as it kind of implements the same contract between the two services, then you can use any container runtime under the hood, and they don't need this shim that they were maintaining and you had to make sure that all your versions were compatible and everything. So they came up with this interface. It basically defines this is what you need to do to start a pod. This is the call we're going to make to you to add a volume. This is the call we're going to make to stop your container. And as long as the runtime implements that, you can then on your node, you can run any runtime you want, any container runtime you want. Whereas before that, it was kind of tied to Docker and the Docker shim. So it's kind of this plug and play model that they came up with. And this is taken from the blog in 2016 where they announced the container runtime interface. And it's just a little diagram showing this CRI shim, this sort of yellowy box in the middle, as the interface kind of thing between the container runtime and the kubelet and Kubernetes essentially. So that container runtime box can be anything now that implements the container runtime interface, which is why we've got this proliferation of container runtimes, because it became so easy to swap them out, to change them. You can even have a Kubernetes cluster where you use different runtimes on different nodes, because it all works in the same way as long as they run the container into the CRI shim. They implement that interface. So you might be able to specify your banking workloads run on specific nodes, which have a specific container runtime, and then everything else runs on containerd because it's the industry standard and everyone uses it, and it's very widely used and widely supported. Do we have any questions that have come in? We're running pretty ahead of time, so we've got plenty of time for questions, or we can potentially run into containerd stuff.
On the screen.
Let me stop sharing. There we go. Yes. Okay. So what you run inside a container doesn't really matter as far as the container runtime or Kubernetes is concerned. So what you would need to do is you would package your application into a container using something like a Docker file, where you say, starting out with the Spring have probably got a base container. So they've probably got a base container, which will be called like Spring MVC, something version 10 or whatever. And then you'd add your application or your jar files or whatever into that base container, and you'd add Tomcat, and then you'd tell Tomcat where to find the application. It's been a while since I've written any Java, so I'm a bit rusty on the details. But essentially, you, as Kunal said, you package all your things into a box, and then you give your box to a friend. But the friend that you give your box to would be what we call a container registry, which stores that somewhere on the internet. And then when you want to run your application, your container runtime would pull that from your container registry. And then it would, it would start the process in the JVM. It would allocate it a certain amount of memory, and it would make sure that it kept running.
The important thing is this one only that Alistair mentioned. Once you're able to create a container out of it, you have to write those files and specs and things like that. Then you can deploy it you can imagine like you're just deploying it on on any server or whatever. So this is something we'll do like a hands-on video on. It's at 5 p.m. I'll show you how you can, let's say, run an application on Civo Kubernetes, and I'll show you, let's say, if you have multiple services like MongoDB and Node.js, for example, how you can bundle that into multiple containers and publish that onto Kubernetes. So I'll show you that as well at 5 p.m. IST, which is the 4th session today. So that's like a complete hands-on session. Please join that one if you want to learn more about how you can actually do these things.
So we've had two good questions come in. We've had one come in saying, what's the difference between a Docker and a container? So Docker is a set of applications and tools that you run on your machine to build and run containers. So a lot of people, including myself, will say, oh, we'll run a Docker container. But it's actually what you're running is an open container initiative specification container. Docker is a set of tools that's used to build these containers. So there's this open container initiative. Basically, Docker was really early on like productionizing and bringing the idea of and concept of containers into the 21st century. I don't know, that's a really bad way of saying it. But containers and process isolation has been going since like the 80s. But Docker kind of came along and kind of polished all of the tooling, brought it together into a set of components that we can then use to run and build containers. But a container itself is just a set of files that are required, and it's a specification that's required to run an application inside a sort of process isolated box. So it's quite the two words like Docker and Docker containers are quite tied together, but that's just because Docker came along. They were like the first mover. It's why do we use Hoover rather than vacuum cleaner? It's because they were the first. I don't know if that translates across the world, but yeah, it's like a Hoover is a brand name, whereas a vacuum cleaner is the generic name. So a container is the generic name, and then everyone thinks about Docker because it was so big, and well, it still is. It's like the de facto way of doing it. And then another good one that came in was, what's the difference between containerd and a container runtime? So containerd is an example of a container runtime. So a container runtime is this kind of conceptual program that will run your containers, it will manage your networking, all the things that we went through. Containerd is a specific implementation of that, just like runc or some of the other ones we put up. We talked about Kata containers and Firecracker. So they're examples of a container runtime.
Yep. There's one on the screen. Should we start learning K8s using Minikube and Helm? I would recommend check out like the Civo Academy. There are multiple ways. Minikube, one thing I would like to recommend is that with Minikube, you can't really access the multi-node like multiple nodes infrastructure, because in that you only have one node on your system that works as both the worker node and the master node. So if you want to like really dive into K8s and try out a lot more things, use something like kubeadm and stuff, and you can use the Civo platform like for that. Pretty straightforward. Actually, I'm the one who recorded the installing Kubernetes videos for the academy. So I've explained like every single way, like play with K8s, Minikube, and kubeadm, and the Civo cloud, like Civo, the cloud platform of Civo, and Civo Kubernetes. So check it out. Yeah.
It also depends whether you want to get into managing and installing Kubernetes as a thing, or whether you want to learn how to run applications on Kubernetes. So if you want to run applications on Kubernetes, then using Minikube is fine. It's the quickest and simplest, easiest way to get set up. It'll just work. But if you want to understand how Kubernetes works under the hood, yeah, check out the videos, check out the other ways of doing it. So yes.
Awesome. Don't see any more questions as such. But yeah, we do have a DevOps Bootcamp playlist as well. It was pretty, people really loved it. It was really nice. So all the previous talks for DevOps Bootcamp can be found on the YouTube channel. I think that was about it. Cool. Hopefully we'll see you around in the future sessions as well. The next one we have is in like 15 minutes. Kai will be joining us on talking about K3s versus Kubernetes. But do take part like in the hackathon, and I will definitely cover today how you can use the Civo platform to run your application. So the theme is open-ended. You can create anything you want: ML app, IoT, web development, mobile development, anything you want. Just the requirement for the price category is that you have to host it on Civo. Yeah, awesome. Thanks a lot for joining. And if you have any further questions, you can ask in the Kubernetes channel, the Civo community channel in the Slack, and there's the hackathon channel over there. So you can ask over there. But yeah, we'll be doing more sessions, and I'll see you in 15 minutes. And yeah, see you there. Thanks, Alistair, for joining. Appreciate it. Bye.